Hello friends, in today's question, a heavy ball of mass m is suspended from a ceiling of car by a light string of mass small m, where value of small m is very much less than capital M, which is the heavy mass of the ball. When the car is at the rest, the speed of transverse wave in the string is 60 meter per second. When the car has an acceleration a, the wave speed increases to 60.5 meter per second. The value of a in terms of gravitational acceleration g is close to. So in this case, we are supposed to find out the speed of the transverse wave as the, you can say, not the speed but acceleration, as the car is moving with a increased speed. So we are going to start from the basic formula that the speed of the transverse wave v is equal to square root of t divided by mu, and then we can take it forward. So we know that speed of transverse wave if given as v, then the v is equal to square root of t divided by mu, where t is the tension and mu is the linear mass density or mass per unit length. Linear mass density and in the first case it is given that car is at rest. We say when car is at rest, car is at rest. So in that case, when the car is at rest, the string will be vertical and there will be a force in the downward direction, that will be mg, the weight, and we are going to have upward direction is t. So in the balanced form, t will be equal to our mg, and let us call this a t as t rest because car is at rest. We can say the tension in the string, which is our t rest, will be equal to mg, and we substitute in the main equation. So therefore we can say that velocity of the speed. Therefore we can say that string velocity at rest will be equal to our mg divided by mu, and the wave velocity when the car is at rest is given as 60. So this will be 60 square root of mg divided by mu. Let us call this as question number 1. In the second case, when the car is accelerating, when car is accelerating with acceleration a, so as the car is accelerating, there will be a pseudo force acting on the block, on the mass capital M, and in that case this was the initial position, and because of pseudo force now the string will be somewhere here, and we are going to have a pseudo force that will be over ma, and in the downward direction we are going to have a mg, and the tension will be acting in this direction, and let us call this as T effective. So we can say, and we can find out the resultant of these two forces, which will be in this direction, and the value will be equal to square root of ma square plus, let me call this as acceleration effective, and the value of acceleration effective we can just write later on. So we can say the effective tension in the string increases due to pseudo force. Due to pseudo force caused by the acceleration of the car. So now the tension is our T effective. So we can say, therefore, T effective will be equal to A effective, and this is equal to square root of, we have here mg whole square plus ma whole square. This has to be capital M, ma whole square. And once again we modify the main equation and write that velocity when car is in accelerated motion will be equal to square root of T effective divided by mu, and T effective will be equal to our m g square plus a square square root and whole square root and divided by mu. And T velocity when the car is in acceleration is given as 60.5. So this gives us that 60.5 is equal to square root of m g square plus a square 1 by 2 and divided by mu. So this is our second equation, and this is your first equation. We simply divide them. Dividing equation 1 and 2, we get this as 60 upon 60.5 is equal to our mg divided by mu and square root, and whole is our square root mg square plus a square 1 by 2 and divided by mu. And mu and mu will be easily cancelled out, so we can write this will be equal to, and obviously m will be also cancelled out, so we can write this as 60 square divided by 60.5 square is equal to, we have this as g upon square root of g square plus a square. Now it is a simple calculation, and we can write this equation as now g square plus a square divided by g square square root is equal to 60.5 whole square divided by 60 square. and this can be written as g square plus a square divided by g square is equal to 60.5 raised to power 4 and 60 raised to power 4, which can be further written as g square plus a square g square is equal to 1 plus 0.5 upon 60 and whole raised to power 4. And then we can use the binomial expansion, and this will be coming as 1 plus 2 and 60. It's almost done now. So we get this as g square, and we have this as a square is equal to g square plus 2g square upon 60. This g square and g square cancels out. So we get this as our, this also cancel out, this comes 30. So if we have a square is equal to g square upon 30, which gives us that a is equal to g upon square root of 30, and which comes approximately says that a will be equal to g, and this comes divided by 5. It is 5 something, but the options that are given to us is our g upon 5. So therefore we can say that option number B is the correct option. We can say option B is correct. So this completes the question. Thank you.